everybody. It is Mike Levin on Friday, January 8th, 2021. And I'm on my weekly drive to pick up my daughter, and I thought I would share my latest thoughts. Definitely right to the professional front this time because it's hot on my mind. I've been spending a lot of time lately automating Chrome, as many people who follow my videos know, and I've been very hungry to put something a little more formal out regarding my learnings in tech from over the years. For those who aren't familiar with me, I'm 50 years old, from the suburbs of Philadelphia, Pennsylvania, which happened to also host Commodore computers for quite a number of years when it was in its heyday as a billion-dollar world-leading computer company. I don't know how many people still remember Commodore computers these days, but back before it was Mac versus PC, it could have been anyone's game. And it started out as the home computer industry, and there was not very many standards out. And then the world changed as PCs won, and their graphics got better, and it became the major gaming platform. And Doom hit as a 3D game, and the Sound Blaster cards were big, and people were having Quake LAN parties at home, and the world very much became PC-centric. The Mac very much a second fiddle, its future in jeopardy and question, and through the brilliance of Steve Jobs' return to Apple and subsequent good decisions, they have continued to breathe more and more life into the Mac, for not the least of which one reason was their move to Unix. Macs are based on the Unix operating system, and we're probably the first major mass production product, pop culture product, mainstream product that used Unix as its operating system. There might have been a few things out there with embedded Unix, QNX and other such things that were in our lives, but really nothing so dramatic as the Mac. And Unix is the operating system that ushered in the, let's call it the information age, because there was plenty going on with computers before then, but it was all very expensive, building-sized mainframes. And not until the Unix operating system, running on merely refrigerator-sized computers like the PDP-7 and 11, did computing come to at least universities, a few people's garages. And this was happening, Unix came out enabling these boxes to be have operating systems in common across different hardware, starting in 1969, 1970. I'm 50 years old. I was born in 1970, so I am the same age as Unix. Being a child of the Philadelphia suburbs, I was also in the backyard of where Unix was born, at the Bell Labs campus in Berkeley, I believe, New Jersey. And I even know people who work there. The parents of people I know were among those engineers, and it's really quite amazing we're that close to that time in history still, and I'm still that close to those physical locations. So, of course, the potential of Unix was not realized until the command compatible, the reverse engineered Linux came out, which started this free and open source contest and race and spinning different versions and customizations. And then IBM jumped in the game with Red Hat Linux, demonstrating that Linux was ready for the enterprise, so a lot of focus shifted from ivory tower Unix to distributed authority Linux. And it was very much in the spirit of the internet, all that distributed stuff. And Linux in combination with the LAMP platform, the LN LAMP standing for Linux, Apache, MySQL, and PHP or Python or Perl, catapulted Linux's popularity for internet tasks and helped usher in the information age. With the big exception of DNS, how website addresses resolved, that was still owned by the Unix world, running on a version of Unix called BSD, which was heavily legally encumbered because it was Berkeley system distribution, BSD, until FreeBSD came along and black-boxed all the Linux commands just the same way, all the Unix commands just the same way Linux had done not long prior to that. And the creator of Linux, Linus Torvalds, was actually quoted as saying, had he known that the FreeBSD project was underway and so far along, he might not have taken up Linux as his pet project, and the world would be a much different place. So anyway, Mac went to Unix. Every consumer electronic device that has some sort of embedded computer has gone to Linux or Unix. And now finally the Windows platform is coming around to Linux as well, with Microsoft having announced that it's likely that PCs will first boot to some sort of minimal Linux operating system under which Windows 10 or future versions of Windows will subsequently be booted, and they'll get in line with the rest of the world. We see the early signs of this already, with Windows being distributed with a full-fledged Linux kernel coming from Ubuntu, which comes from Debian, which is a wonderful free and open source distribution of Linux. Debian is one of those beautifully unencumbered technologies by vendors. There's not many examples of that. Python is one, and you can start to understand which languages and tools and platforms are not held prisoner by parental corporations by looking at the organization under which the language or platform is published. It might be a for-profit company, or it might be a foundation. In the case of both Debian and Python, there is a foundation. So one of the most powerful set of tools, which is also future-proofed and vendor-proofed, meaning you won't suddenly have to pay money for reasons you weren't expecting, would be Python running on Debian Linux. I might be saying Unix by mistake for Linux from time to time. They are not interchangeable. Unix is tightly regulated by, appointed bodies, whereas Linux is almost anyone's game, but with the main boot kernel being under the control of its founders. I believe Linus Torvalds. It might have gone to a non-profit organization. And so let's see, where am I going with that? Yeah, so this is on the professional front. So if you want to write stuff and magically have it come to life and be running and be using all standard stuff that will not go obsolete for a very long time, or the obsolescence cycle is very gradual and it's not radical and you're not forced from thing to thing very fast, you would do well to take up the platforms of Linux and Python. put together to get your software running. And because Linux can run on almost anything, and consequently, Python can run on almost anything, one of the great art forms is to get the stuff you write to run on almost anything. It's the Sorcerer's Apprentice trick. If you don't know what I'm talking about, watch Fantasia, Mickey making the brooms come to life to do a task for him. But unfortunately, in that case, things getting out of control in what we would call in the tech world as a network bit storm, feedback loop, where the instructions issued by Mickey allowed too many brooms to be created in that work area in space. So anyway, I think very often about what I have to contribute to the world, and when I do clean up my offerings, what it's going to look like, what the topic is going to be, how I'm going to do it on the various media, what portions of it are going to be free, and how ambitious I am, how far I want to take this. I am inspired by many people out there. I am certainly not a business person nor very financially money motivated, or I would have taken very different courses and paths in my life. And I look out there and I see people like Linus Torvalds, the creator of Linux, and Guido van Rossum, the creator of Python, leading very humble lives. Although Guido was tempted out of retirement to go to work for Microsoft in its ongoing effort to own the Python platform. And we have to all watch and be careful that Python does not get embraced and displaced by Microsoft. And as happened with Java is massively less popular than it used to be, having gone from a language, from a ragtag company, Sun Microsystems, a very analogous company to Commodore computers. What Commodore was in the home computer industry, always putting out the best deal for the money, Sun was in the, we call it the personal workstation market, as defined by the Sun workstations, and a lot of Lisp machines were out there at the time. The Apollo, HP was in the game, but a high-end kind of computer graphics, think the early days of movie graphics, stuff that led to Jurassic Park. Those computers were Sun Microsystems and its ilk, and one of the employees of Sun Microsystems created Java, and Java had this, free and open source feeling, but then Sun was bought by Oracle, which is the complete opposite, the antithesis of Sun Microsystems. And then the Java programming language itself got quite tainted by that, as MySQL did. So that's the M in the LAMP platform: Linux, Apache, MySQL, and Perl, PHP, or Python. So of that original LAMP platform, the A, hardly anyone starts new projects on Apache anymore. It's Nginx or other approaches that rethink the whole need for a web server. M, which was MySQL, people rarely take up as their new database anymore. Again, rethinking their need for a database, or using one of the plethora of other options that are out there these days. Postgres, Redis, SQLite built into Python, all kinds of options. So, and then the P in LAMP, I guess plenty of people are still using PHP because of Facebook and such. But, P is pretty much owned by Python these days. There was an honorary Ruby thrown in there when Ruby on Rails was the big deal. But most large projects built on Ruby on Rails have been refactored under Scala and other languages. Because Rails, while it was good for the noobs jumping on board, had definite scaling problems and mainstreaming ecosystem problems. Perl is not Python. Python has this vast ecosystem of different platforms it runs on, different high-end niche packages that have been made for it, general and niche, from the Pandas library to do data manipulations to robot control and drivers out the wazoo. So anyway, although I might be misspeaking when I say drivers, oftentimes drivers are under, well, no, they're part of these packages, but under other languages, because drivers need to be written in these optimized languages like C, and then wrappers are written in Python to access those drivers. So it's the combination of drivers and wrappers that exist for Python. And I would just say access to control many software and hardware platforms and systems already exists in Python. Just look at the PyPy index of different things you can just get for free in Python. So many tangents here. Let me try and stay on track. So, what I have to offer, I believe, is bridging the gap between the sort of ad hoc scripting world, because they call these languages like Python scripting languages, which does them a disservice considering how powerful they truly are. But all the things that developers of scripting languages do to make sure these things remain accessible to the newcomer, lower the barrier of entry, and have allowed, through the additional efforts of companies like Anaconda, noobs who might be high-level professionals in their field, whatever it may be, but noobs that are scientists and financial analysts and business people and anyone who has to handle data in their profession, to take up the Python programming language easily by virtue of using it through the web browser. Anaconda is a install that it's a company, a foundation, I believe, a for-profit company who puts out free and open source tools, but it pre-installs all that stuff that is hard for the noobs. I mentioned drivers. Drivers are hard to get on your system. Python is easy to get on your system. So when you sit down to take up tech, if you're on the world's most popular developer platform, which is still Windows 10, like it or not, and you research how to start using Python, you will discover that all you have to do is open a Windows terminal or command shell and type the word Python, and you will be brought to the Windows Store and easily be able to install the latest, greatest, and official Python on your machine. And then you can start creating Python.py files, a text file with a .py extension. Feed it to that, what you just downloaded, currently Python 3.8, and your code will run. However, there are tons of questions unanswered. Under what text editor will you, or IDE, will you write your code? Microsoft tries to get you to use their IDEs. The free and open source one, whose popularity has taken off like gangbusters, is VS Code. And it's not the overweight IDE, which shares the same name, basically. The VS in VS Code stands for Visual Studio. So if you were to just Google Visual Studio, you might still be brought to the heavyweight, non-web app oriented Visual Studio.net or whatever. It used to be Visual Studio.net, but high-end thing. And Microsoft might even still be charging money for it. It installs tons of stuff on your machine versus VS Code, which is fairly lightweight, which is built using web platform tools. I think it might even be Electron, Google's tools for using the components used to build Chrome for building desktop but very web-like applications. And it's also free and open source except for a few components of it which are not. So it tries to give you the comfort level of, yeah, you're using free and open source tools and it'll be around forever. However, you will notice this trick that's occurring. I want to do Python things. Oh, it's available through the Microsoft Store. Oh, I can edit it with a Microsoft IDE, Integrated Developer Environment, and it will run on my Windows machine. And you will kind of be led down this road of platform dependency. It's not as bad as it used to be in the past, but you are being sort of rallied into the Microsoft family. They're getting you familiar with their way of working, their user interface paradigms. Hate using that word, but it very much rewires your head. The drop-down menus. If there's any question that VS Code is different than other environments, if there's any question that whether or not you're being locked in, just load it up, start using it, and you'll see that you're going to be a VS Code person. The tools I advocate, you will absolutely also be a Vim person or a VI person, but the type of free and open source we're talking about is quite different. In the one case, you're being locked into the Microsoft way of doing things, and in the other case, you're being locked into a utterly free and open source, I believe no strings attached way of doing things that has been around for approximately 40 years in one form or another since VI, the text editor it was based on. You could even go back further to single line editors, but that's too obscure of a conversation. But because you can go back to VI, which is part of a lot of the standards of what Unix is, you will tend to find an editor that you will be able to load up and use by almost telepathic thought control muscle memory. You will get to know it so well on almost any machine you sit down on, from Mac to PC to Unix to Linux to even other kooky things that may still be out there. You will either already have the VI or the Vim text editor on there, or it will be a snap to get. So and the muscle memory you get, you'll just be able to sit down and be competent no matter where you are and no matter when you are. You might think that's your future when you go the VS Code direction, but I assure you it's not. It's a whole nother video to qualify that statement. However, load VS Code. I encourage you to have it in your toolbox. Use it from time to time. Maybe use it as your backup text editor instead of Notebook, so that you're forced to get familiar with its user interface, because it's a nice tool to have in your back pocket. But what I'm saying is the better tools, and see, I was discussing Linux and Python. Now we're up to your code editor, which could be anything from an integrated developer environment, which does all sorts of fancy features that are common expectations these days, from color coding your code, to auto indenting, to having this interface where you start to type a command and it either tries to auto-complete or pops up little interfaces that you can choose. So when something is this dot that, you can sort of drill down and not have to learn all the ins and outs of a language. but rather have your IDE sort of attempt to auto-teach you, automatically seeing the methods of classes and stuff like that. Or you can go with a much more stripped down text editor. There's plenty out there. There's still people who code in Microsoft Notepad that has been around forever and has been dramatically upgraded of late, I'm happy to say. It doesn't have its weird shortcomings of the past, of file size limitations and one font size. It's now quite nice. You should be able to pick up almost any tool and use it competently fairly quickly. But you should have a small set of tools which become extensions of your body, which become deeply internalized, which become like your hands and feet and fingers and toes. And that's certain portions of Linux, the broad strokes of Python, a lot of Vim, and then the last one, Git. I don't want to turn this into just another Go, Linux, Python, Vim, and Git as sort of a developer stack for life video, but all roads do lead to that message, but it's a more complex message than that because there are so many other tools worth using, and you will often find that the lower level languages or the easier languages are just providing doorways and wrappers and ways into other languages. So, for example, one of the main tricks I will be advocating, going from the world of noobs, where you install Anaconda and start coding some Python in the web browser under Jupyter Notebook, in the data scientist way, I might add. Tons and tons of people who need to do complex things with data do it in a notebook environment, which sprung out of academia, I might add. Jupyter Notebooks didn't invent this. The concept of notebooks comes from people such as Stephen Wolfram of Wolfram Alpha, who I believe it's Mathematica, if not it's Matlib or Matplotlib. There's all these different things. Maple is another one of them. These are these packages that were born in academia that allow students to both execute code and take notes about the code that they're executing, so they can write dissertation papers with a little bit more life and accountability to them than just with paper and PDF files alone. These things had $2,000 per seat licenses that came down to $1,000 or $500 with a student license, but that was still terribly disappointing for people who came to rely on these tools and wanted to use them, say, in business and scale out their apps and collaborate with their coworkers. They could not be so license encumbered. So various tools came into existence. One of the more popular ones is the R programming language, and then IPython, which was a precursor, a predecessor to Jupyter Notebooks, that allowed you to run very, sophisticated algorithms in R. R is a free and open source data science language. It's a specialized language, more of a specialized language for data analysis than Python was in its day. But Python, being a general source language for which lots of people are writing packages for, has been improved and improved with lots of packages from NumPy to Pandas to Xarray that allow all these data science type things to occur. Some would argue just as well under Python as they did under the R programming language, but because they were such neck and neck contenders with strengths in different areas, Python being that you could take your stuff to system automation more easily, scheduled automation, web server, serving web server requests better than the R programming language, and R being better at the sophistication of the analyses packages, the packages available for R. They were both included under IPython, the precursor to Jupyter Notebook. So even today, when you install Anaconda and fire up Jupyter Notebook, you can choose between R notebooks and Python notebooks. In not long, I'm sure JavaScript will be in there as well. The JavaScript world, being as popular as it is, has its own package out there. I forget what it is, JS Data, something like that, which is a pandas-like package. But whereas Python has things like scikit-learn that has tons of packages that can apply to pandas data frames, there's this level of maturity on the Python side that's going to take the JavaScript world a while to catch up with, and I think it's just as likely as JavaScript being included as a native language under Jupyter Notebooks as the new packages being matured as their own standalone contenders under JavaScript. Anyway, these are, again, tangential discussions, but there's an easy road into doing sophisticated data analysis stuff. Not just analyses, but data collection stuff, especially when you start with Python. You can deal with all the authentication issues of getting to your data, because every authentication problem has really been solved under Python. If you're starting out in R, not so much. But you might want to use R here and there to do things. And for that matter, you might want to use JavaScript here and there to do things, because stuff gets embedded control languages. I'm trying to think how to put this, but no matter how much you'd like to choose one language to rule them all, be it Python or JavaScript these days, you will always find things that either specialized languages do best, in the case of, say, the Go language, with compiled true parallelized concurrency for systems development work of the sort Google does, who, by the way, tapped the founders of Unix itself, Kenneth, oh my God, I've been talking a lot. How can I forget these names? But Dennis Ritchie, who's passed away, who did the C language, and Keith Thompson. Anyway, the creator of Unix, together with Pike, who was the creator of a bunch of file system stuff, were tapped by Google to create the Go language. So basically, the founders of the modern information age also created the Go language from Google. So occasionally you'll find yourself needing to use specialized languages, or languages that are embedded into things as control systems. A language called Tickle, or TCL, used to be used for this a ton in the past. Another language called Lua was used for this a lot. And more Python is being used for this. General purpose languages that can do a lot of list processing. You'll find the L in languages like TCL, often standing for list. Even in Perl, it's always about list processing, iterating through, sort of stepping through items in a list and doing something for each item in the list. So the language needs to be list processing oriented and not very license encumbered, because Company B is taking company or organization A's language and embedding it as a control language into, product B. JavaScript is also one of these languages. ECMA, European, whatever, I forget how it translates to, but JavaScript is actually officially known by another word, an acronym, which comes from one of the European standards organizations. So it is a standard, just like Python is a standard. The Python that most people know and love and execute is the one that comes out from the official Python Foundation, python.org. It's the one you actually get when you type Python into a Windows 10 command line and it starts to install it from the web store. You're getting the good stuff. It's the specification. It's the language that was published by the organization that puts out the specification so that there's a standard against which everyone else can compare their implementations. But most people don't use those other implementations. PyPy, a different PyPy than the package index I mentioned earlier, but PY, I forget, one is PYPI, Python Packaging Index, PYPI, Python Packaging Index, and the other is PyPy, I believe it's PYPY, which is a different implementation of the Python specification that handles things a little differently, so it's faster and things compile better. And it uses fewer of the dynamic list processing features, which are so popular but speed challenged under the standard specification, but everyone uses it. It gives Python a bad name on the speed front because of the dynamicism that the Python interpreter reserves so that it has lots of your machine's resources for crazy stuff people often want to do. Ragged arrays, where members of those ragged arrays can be blobs. Anyway, lots of sub discussions there and videos there. But Python is a strong suggestion. JavaScript is a strong suggestion. We see Google implementation heavily used in what was once called the V8 engine. That's at the heart of both JavaScript that's embedded into the Chrome web browser and the Node.js web server component. And also all the Google Cloud services, they all use the Google implementation of the JavaScript ECMA specification. So there's embedded languages. Strong argument for why, if you are choosing one language to rule them all, JavaScript is not a bad choice. I'm not steering people away from it as much as I may have in the past because it's maturing at such a rate that every argument against JavaScript will be invalidated. Many of the syntax arguments, the scope arguments, and the brevity of code arguments have been wiped away by something called arrow functions that came out recently in JavaScript and can allow much more Python stylistic coding to be done. And we see this happening so rapidly on the JavaScript platform that in not long it'll be nearly curly bracket free if you want it to be and have many of the advantages of Python. However, I digress again. When you pick up a language, or one language to rule them all, picking up one of these control languages would not be a bad choice because they are traditionally not very license encumbered, so that company B is not screwed when company A changes their terms of service and changes their licensing. But Lua and TCL have not sort of made that cut. JavaScript and Python have good languages for 10, 20, 30, 50-year career time frames. So embedded. Oh, yes, so if you jump on the Python bandwagon, you will not get away from having to learn some JavaScript because it is the language of web development, but it is embedded into the browser, which you would like to control as an external device. Forget about the language of web development and user interface work, human UX work, and all that, jackpot code that is all the rage these days. How long do you really think React.js is going to be around? Oh, React.js is it. Oh, but no, Vue.js or Vue is taking over. How long do you think Vue is going to be around? What you have with React and Vue are compensations for weaknesses that the platforms they're based on were not good enough. And it took all this time for things like jQuery to just make JavaScript usable to no longer be needed through the maturation of the JavaScript platform itself, to the point where you no longer really need to specifically be importing jQuery anymore. You can get away with most things under vanilla or non-library assisted JavaScript these days. However, you will have to take up React.js or Vue, except who am I to talk, because even on the Python side, when I tell you to install Anaconda, I'm telling you to install all these other packages. So the discussion is becoming much less of a jury-rigged web development language of JavaScript versus a highly mature back-end but web-weak language of Python, or mobile-weak language of Python. Python has weaknesses, no matter what people want to say. Currently, it's as a mobile development platform. Whereas for mobile development with JavaScript, you got tons of choices. Anyway, you're using Python, and the day comes where you have to automate Chrome and the web browser. You're now doing you're doing control of an external device through its API. It gets to choose the API that it likes, and Chrome chose JavaScript. And the Puppeteer library has been written to ease the control of Chrome. And things like Chrome have to have some protocol, some API. And this, I believe, is called the WebDev API. So what's really happening is Chrome has this API built into it. The WebDev API, I believe it's called. I may be wrong on this terminology, but the Puppeteer library speaks to that. And that makes you able to use just regular JavaScript, familiar commands in JavaScript to control Chrome. Now, they force you to work in a new mode of JavaScript that came along a few years ago to solve all these API problems of concurrency and non-blocking I/O. First in JavaScript as the Ajax world, because we're talking about the Ajax world where commands can be issued by your application, and while things are being fetched usually over the web and the internet in the background, things can proceed in the foreground, namely your user interface is not locked up. You don't feel like you're waiting for things to complete. That's why this is a so JavaScript and web-driven force, because people got a taste of concurrency and non-blocking I/O, and they said, "Ooh, I want more." And so the JavaScript people said, "Oh, here's callbacks. You can use this callback API." And so now there was a little bit of formality to this Ajax stuff, but callbacks became hierarchically deeply hierarchically nested, and a pain to keep track of. So, to ease that, promises came along. Promises made you not need to use the callback API quite so much. Promises are nice, however, it's still mentally challenging. It's still code bloating. It still makes the world of concurrent coding so radically different from the world of sequential programming, non-asynchronous programming, procedural programming that so many people are used to, and it works so much more like the human brain would seem to work. You will get both opinions. Do people think sequentially or do people think concurrently? And you'll get both opinions, and it has to do with sub-processing systems for different type of information. So your nose and your eyes and your ears and your equilibrium and all your senses basically have their own sub-processors, which is why humans seem to be so good at multitasking. But when you're funneling it through your language centers of your brain and funneling it through your vocal cords and your broca, you seem to be, and think things through. When you say, stop, let me think things through, you seem to be single tasking. And then you go, oh, humans aren't great at multitasking. Well, how about all this other stuff? Well, yeah, humans are wonderful at multitasking, or else your heart would not be beating. Humans are not great at cognitive multitasking, consciousness multitasking. Consciousness is mostly sequential, with the exception of intuition, a whole other sub-discussion. So, we like to write scripts sequentially. This happens, and the next line down, the next thing happens, and the next line down, the next thing happens. And even promises did not let you code in JavaScript that way. Things were very non-sequential. And then when you had things in separate files, and they're also non-sequential, it gets very confusing. There's this issue where computer science-minded people who are doing computer science-minded things for life get good at this, and they'll tell you, oh, that's all so easy. Yeah, well, with a 4-year computer science degree, formal training, and lots of forced practice and exercise, it'll get easy for you too. I might also add a lifetime of commitment and exercise, because the concurrent world makes you think things through much more deeply than the sequential world every time and on every task. There's similar arguments to be made with object-oriented versus procedural. And I happen to be a non-object-oriented thinking person, procedural being the alternative to that, one of the various alternatives, functional being another, so many sub-discussions. But I tend to be a procedural imperative. No, imperative is yet different. Imperative would be SQL or HTML, which is yet another language type, heavily markup and English language oriented, like SQL or, So there's functional, which leaves no traces and has no side effects. There's procedural, which is most things that are familiar to people, the whole tradition of languages that are algol-based, which includes C and C++. And then there's, functional, I should name some languages. That includes F# and Haskell, and things that are purely procedural or things that are purely functional are kind of weird. Functional is such a misnomer. There's procedural, which is what most people are familiar with, and then there are object-oriented, where things are this, dot, that, and honestly, C++ is object-oriented. That's where the that's what the plus represents. I kind of feel I'm rambling. I hope I'm not losing too many people. I'll try and clean up this discussion a bit. But I'm telling you, I'm weak in the head. I am not a comp sci person. I don't do a lifetime of dedication to the language I use to express myself. I do a lifetime of dedication to expressing myself in a free-flowing and sometimes structured and automated way. And I'm here to bridge the gap between that more artistic, free-flowing data scientist, Jupyter Notebook, Jupyter Lab, IPython, Google Colab, because now that Jupyter Notebooks has become so massively popular and successive and embraced in the whole world, not just the academic world, not just the financial world, but by the whole world. Microsoft and Google both recognize that threat. So they have, of course, cloud versions in the form of Microsoft Azure notebooks and the more popular Google Colab, which are both Jupyter notebooks, and Microsoft embedding the Jupyter Notebook engine, the Jupyter engine, into VS Code once it notices you have done the Anaconda install, to get many of the notebook type features under VS Code, more of the siren song allure of the vendor to slap some golden handcuffs and lock you in. The extent Microsoft will go to lock you in is astounding, and it includes taking most of the advantages of the Jupyter Notebook and notebook environment in general and putting it into their free and open source IDE to keep you from using generic notebooks. But if you do, you should be using the Microsoft Azure ones. So the process of giving it away for free, giving away unbelievable, amazing amounts of stuff for free, which is always happening somewhere in the cloud to keep you from using someone else's stuff, is currently happening under Microsoft's cloud-based notebook offering, Azure Notebooks, and Google's cloud-based notebook offerings, Colab. Very, very clever name. Because you're collaborating oftentimes in a lab, an academic environment, collaboration. So to the point where more people will be exposed to this through Google Colab and then be carried along to the Google Cloud platform or to the Microsoft Cloud platform. The whole thing here is, oh, I'm interested in notebooks. I hear notebooks are a great thing. Well, here's Microsoft Notebooks, here's Google's Notebooks. Oh, I don't even need to install Anaconda. No, you don't. Oh, and I can share this link and collaborate with all the benefits of like Google Suite, Google Docs, Google Sheets. Yeah, you can. Oh, and we can work together, and it's beautiful, and the world is a wonderful place. Bada bing, bada boom. You can't get paying Microsoft and paying Google out of the picture before long, and all your muscle memory becomes hardwired to their very proprietary tools. And you're right back where you started 20 years ago on Microsoft Office or on SQL Server or on Oracle or on SaaS or SAS, not to be confused with that. I'm thinking they're two very similarly named things in the tech world. The SAS compiler for CSS style sheets, and I guess the notebook contender for data analysis, because when this stuff is used in the high-end paid consultancy world, they don't use the notebook product. So you learn on some notebook product in school, say MATLAB, and paying the license fee. You go out into the business world, you know everything is money driven. You discover SAS and you become a locked-in consultant working for one of the big consulting firms using that software. So if you want freedom, you start out on R or Python for those same tasks. The tools will not be as mature today necessarily as they are on SAS, but just the way the R tools are maturing on the Python side, and you'll eventually not need to use R. But if you do, you can use it as a externally controlled device, the same way you use Chrome in browser automation. You can use R as a controlled external device in ways I will teach you. That'll be part of my gig. You'd think through Python, but no, Linux is the glue that binds it all together, and basic Linux scripts are the initiation of scheduling on any machine you take control of by stepping in and taking control of its boot script. So the main trick I'm here to teach you, and talk about burying the lead, I'm here to teach you how to jump on the bandwagon in the noob data scientist way onto Jupyter Notebooks, onto Python via Jupyter Notebooks, via Anaconda, via your host operating system, be it Windows, Mac, or miscellaneous Linux desktop, on all of which you can install Anaconda and get Jupyter Notebook and Python through your web browser. So they solved a really big barrier to entry problem, for which the check mark was in the JavaScript column because every web browser ran JavaScript. So just add some sort of text editor and you can do some JavaScript on any machine. But now on any machine you can do some Python through the web browser as your editor. I cannot emphasize enough how much of a difference this makes in lowering the barrier to entry for the noob, and how important it is to deeply consider your VS Code decision before you jump in head first and kick the tires on these other notebook products that are not VS Code, even if it's Azure or Azure Notebooks or Collab. Better emulation of notebooks than bastardization of notebooks. Though you get many, many wonderful, powerful IDE features on VS Code. But if you're in it for the IDE features and you're in it for Python, you can do even better by going to PyCharm. So there's lots and lots of nested sub-discussions here, and I'm not steering you wholeheartedly away from the power tools. I'm just telling you, develop your muscle memory on the truly free and open source, obsolescence resistant, unencumbered by licenses, tools on which you can develop muscle memory, and always have viable approaches to tech challenges in your back pocket, almost no matter the conditions, the circumstances, the settings. There comes a point that when you've mastered Python and enough Linux to get your Python code running on almost any hardware platform, that there's not a problem that you can't undertake and be one of the viable contributors to the project, one of the valuable contributors at the table. The same is greatly true of JavaScript, but you just won't have the same access to packages for your area of specialty. Pandas being the biggest example today, but drivers for almost every known piece of hardware and control system being the long tail example. If Pandas is the fathead example, drivers written for this and that device, or for SQL engines, or for robot control or droid control or embedded systems, being the long tail example. So no matter what your JavaScript jackpot pursuing fashionista friends are telling you, the discussion does not begin and end at JavaScript, but rather JavaScript is the control language du jour of a popular platform. That platform being the web subplatform, a platform that is available within other platforms that seems to give you that cross-platform future proofing, but not really, because when it gets to pure systems work, I'm tempted to say pure systems work, but for that, the Go language does a better job. So when it gets to approachable systems work by non-comp sci career professionals, Python is a profoundly good choice and has lots and lots of life in it, has been around for pushing 30 years, not the 40 pushing 50 years of Unix, but nonetheless long enough that you can feel confident that it's in a different category than many other tools that you will find out there. People won't want to admit this on this basis. They will say that even Perl is a better language, but do remember, even back in the early days of this stuff, when the LAMP platform was the accessible way to this kind of tech, the P stood for PHP, Python, or Perl. Python was right there. So why not PHP? Well, because it's an embedded web language. Again, it was a language made for template work, and it's only recently been extracted for systems work, and has to undergo all that same maturation, and is far behind Python and third-party packages available to install. JavaScript is moving fast on that front with the NPM repository. And Microsoft bought NPM. It was not an independent foundation or anything. Microsoft also bought GitHub. Microsoft hired Guido van Rossum. Microsoft made VS Code work like Jupyter Notebooks. Microsoft is shipping the Linux kernel with Windows and making Python able to be installed with a single word. Microsoft has announced that PCs will boot first to a lightweight Linux environment, which will then subsequently boot Windows at some point in the future, which means Linux 1 even on the Windows side. Such convolution of labels and mental acrobatics. But if there's one takeaway, Linux 1, and Unix on the Mac side is honorary Linux now, because you learn Linux, you're learning Unix for the most part. Big differences in the repositories and how software is installed. The two big contenders there on the Linux side being the Debian repository, which is also the Ubuntu repository, which is also the Raspberry Pi repository. It all derives from Debian. And then there's the Red Hat repository, RPM, which is the Yum installer and all the other ways people know to install software on the Linux side. So the two contenders are really the Red Hat, which is IBM. It's the Red Hat IBM RPM camp, and then there's the Debian Ubuntu Raspberry Pi Microsoft, I might add, camp. And Unix just doesn't have that same thing because it's not as rooted in the free and open source world. So less drivers for device control, more proprietary. We choose Unix because we want to control it down to the byte kind of mentality. Why Apple chose Linux? Why Apple chose Unix for its boot kernel on both the Mac and iOS, right? So, but you learn Unix, you learn Linux, you learn Linux, you learn Unix. For the most part, there are plenty of differences. They are not synonymous, but they're command compatible, with the biggest differences coming in the repositories that you use to get the free and open source software. Okay. Anywho, that discussion gets back to the fact that Linux is ultimately always in control, because you take control of the boot sequence and you install your own scheduler under the language of your choice. So I choose to use a Python scheduler. So control of a machine when it boots up, it's first under control of the machine's own specific, for that specific hardware boot code. It's very, very tiny. That hands control to the next thing, which can be changed usually. It's not committed to hardware like the first piece of boot code where it tells it to where to find its subsequent boot code. It's been known by many names over the years. Boot track, NB, like, well, it's a boot track, so it goes from hardware to software for the boot process. Not an operating system yet, proto-operating system, real low-level stuff. Then it goes to operating system, and usually a stripped-down operating system, and usually it's about a third handover, sometimes a fourth handover, until the operating system that's really controlling your machine is the one you know and love is in control. Even a fifth to get a desktop, but it's handed over, handed over, handed over. And so what I'm going to teach you is all you comp, sci, notebook type people, how to get to control that boot process so you can insert your own scheduler, so you can insert something very much like your own, like your notebook into the process. But I'm going to teach you how to clean up your notebooks to be ready for server-based, hands-free, end-to-end automation. So we're going from noob to IT professional, from exploratory work, from the REPL environment where code is always sort of running and you can inspect the values of variables, pick up where you left off, do experimental work, hit an API for the first time, play around with things, do data manipulations, visualize things with all the various chart and graph and animation visualizers that are built into Anaconda. I might add, you have many choices when you want to visualize data. If you go the route I'm recommending and install Anaconda, and go from that exploratory world that is mostly dominated these days by data scientists, to the automation world, to the hands-free, end-to-end automation world, which is where I live. It's where most of my value comes into play, because almost anyone can get things running once and with tender love and care be able to tweak parameters and not worry about memory leaks and efficiency and optimization in a Jupyter Notebook environment. If you run out of memory, you outsource the processing portions of it to the cloud, or you install Dask and make it take a longer time on your machine. You would install Dask in either case. You can make it take longer to get a job done that your machine would not normally be capable of because of memory limitations, or you can map reduce it out to, potentially unlimited servers out there, with all these Amazon, per usage processing services. It's kind of like cloud services, but they call it serverless processing. There's very much servers in the picture, but with serverless processing, you can take generic Python code that can map reduce, install one package Dask, and then map reduce it out over the cloud and finish something thousands of times faster than you thought it would have taken, with just a little bit of money, of course. Or you can take a project that your machine was timing out on because you don't have enough RAM and make it eventually finish, because Dask does the opposite of, farming out jobs. It'll feed a huge job through a very tiny pipe. So anyway, I'm probably digressing a bit, but what I'm saying is that when you're a data scientist and you're in a notebook environment and you feel like you're forced onto the cloud to have enough room to process your data, and you feel like you're being forced onto Azure or Colab, you're not. You're just use Dask and then use any cloud service to do your heavyweight processing without vendor dependence. Or pay it a little bit in time and get it done in the hardware you do own, and get to use generic notebook. notebooks, because with generic notebooks come all the many techniques you can use to get that same code. You're doing an exploratory ad hoc REPL, read, eval, print loop, student-like environment, learning environment, noob environment, and move it over to true server automation where people can rely on it, where your neck can be on the line for delivery of reports and you know they'll get delivered. I have many of those types of things running right now, and I will tell you there's so many little nuances in going from a ad hoc exploratory notebook job to a ongoing scheduled job. I can spend the rest of my career just zeroing in on that professionally in my clock punching world, where I'm not leaving. That's why I'm not a YouTuber. That's why even though I can just talk forever on this stuff, I'm at 1 hour and 11 minutes. This is an awesome video. It may have been one of my best of all time. I'm going to continue to draw a salary because the kind of stuff I do, it's perfectly oriented for salaried situations, because you spend your available time working on ad hoc one-off projects. Every once in a while, an ad hoc one-off project is promoted to 24/7 scheduled server reliable project. It is not web development. It is the path less traveled these days, but by getting web development, which is basically two big problems, getting a server to say, hi, how can I help you? What can I do for you? How you doing? What can I do for you? How can I help you? As unreliable as it can be, oh my God, there's so much there, how to get a server to keep up with demand. Or it's a user interface going, oh, this is the most intuitive, natural way you can work, and the best distillation of concepts to human, consumable way where everyone has their own opinions. So web development is one of these two things, making a server go, hi, how you doing, as fast and as well as it can, making you a genie on a leash for the rest of your life. Or it's another kind of genie and magician, making the best user interface, using the most fad-driven, techniques and styles, and always racing to keep up with the Joneses and the next framework. So, there are other, choices in tech. It's got this terrible moniker of back end. Moniker is a terrible word too. The nickname for non-web-based development is its biggest enemy in people taking it up. But if you want to move transparently, yeah, that's my goal. If you want to move transparently between the world of notebooks and super reliable server automation to deliver as a fully baked deliverable to your stakeholders, pop arriving in their mailbox, things that is of profound value because you pulled data, you transformed data, you applied complex libraries, you formatted, and you made it usable. So you might say, oh, that's user interface work, but it's not. You're just making pivot tables and pie charts. It's not the same as web development work, trust me. At most, you'll be making interactive web, charts and stuff where you can look at changes over time with sliders. There's a lot of exciting things going on in there in the Python world with notebooks. But it's still not nearly as complex as true web development work. So you use all that excess capacity to deliver ad hoc deliverables. What if we do this? What if we do that? What if we scrape these search results and correlate it with these external API data services, and then did these additional processes and filters and transforms and sorts and data modeling and such, and then put it in some format highly consumable by the stakeholders so that they can make better business decisions and make this as real-time as you can from the systems. Well, true real-time would be web development work. If it's not true real-time and every day is good enough, then the technique I'm talking about is good, because you're basically making static printouts. You know, it's the same as the discussion of how static text was better for the web for so many years because web servers were slow. But now that web servers and caches are so ridiculously good, you don't have to worry about your dynamic code as much as you used to, and you don't have to flatten your site into static text files quite so much anymore, because it's such a solved problem with more sophisticated things, which are basically flattening it to text files. They're just hiding that and calling it a cache. Yeah, so 80-20 rule. 80-20 rule. I'm advocating a different way of working than the web dev way, a different set of tools than most people use, although they are timeless and fundamental and ultimately relevant and highly obsolescence proof and have low learning curves with the exception of the Vim text editor, and which are the P in the pool of tech. You will never be getting away from them. Machines will always be doing some sort of Linux boot process, how to step in and take control of that boot process, how to insert things like schedulers in the language of your choice, how to keep that one scheduling task running through the use of daemons, which are basically services running in the background. Microsoft people know them as system services. Linux people know them as daemons. But you only need one, and it's your scheduler. And then that scheduler can in turn, through the Linux API, even though it's under the language of your choice, I would still recommend under the Linux API, because it creates interoperability between all languages under all conditions and all environments, because the one master environment is Linux. Linux can invoke any language on the command line using parameters. So you learn how to turn all your code into command lines, or into commands that are usable on the command lines that take arguments, and then with the language of your choice, you execute that Linux command under a scheduler. Oh, so beautiful. You can do this on one machine. You can do this on thousands of machines. You can use deployment tools. You can use Git as your deployment tool. Linux, Python, Vim, and Git, the fourth item in that thing, can be your deployment tool combined with a scheduler across thousands of machines. It becomes a little unwieldy then, and you'd like to use some packages that are built specifically for that, or else you'll find yourself building packages around Git to do that. So just research yourself some packages. And I think I'm going to wind up there because my face turned red in front of this red light, and I'm about to be where I'm at. And yeah, Linux, Python, Vim, and Git, noobs, starting with the Anaconda install, taking up Python, doing notebooks with an exploratory, wonderful environment for noobs, where data scientists are today prevalent, cleaning up those scripts for memory clean running on your server, database clean, cache clean running on your server, so your servers don't stop running and you don't have to break the bank on cloud database stuff to warehouse your data that you're never going to use. Cleaning it up, moving it over to a server, keeping it 24/7 reliable, running on that server using spawn retaskers, your favorite language, Linux commands, which are actually programs written in your favorite language, to keep your reports flowing, sending out through email, triggering notifications. And I even have such wonderful stuff as triggering a notification to let you go in and monitor your scripts running on the server by logging in, knowing to go log in through your terminals, the GNU screen terminals under which I run all tasks, so that they are monitorable and not these invisible scripts running that you have no access to other than looking at a log file. No, You can look at the actual command line where they're running as if you triggered the command line on your local machine. It's just happening by a schedule on a server, but you can log into it from your desktop machine and look and see it running. And you can schedule something to notify you beforehand to go and look and see it running. And that is a powerful tour de force career plan. Feeds the soul, feeds the mind, and feeds the wallet. Highly in-demand skills. Makes you obsolescence proof, makes you always relevant to the projects being done, allows you to have a primary language where you develop spontaneous mastery, where you become incredibly expressive, where you can become expressive in automated systems. They are semi-automated on the notebook side, fully automated on the server side, but you get spontaneously expressive in the notebook experimental side as if you're just speaking a spoken language. And moving it over to the server side by just cleaning up your language. And that's it. Linux, Python, Vim, and Git, honorary notebooks of all sorts, taking advantage of the cloud, taking advantage of best-of-breed external third-party tools, using Python to using Python to wrap and invoke other best-of-breed languages and tools. So sometimes you can avoid complete relearning of other sub-languages by using Python wrappers, and sometimes you can't, like in the case of Puppeteer right now. So for Chrome automation, and there's my message. Don't forget to subscribe for those of you who watch this entire video. Wow, thank you. You guys are amazing. You guys are awesome. I'll clean up my videos and make this much more consumable for the masses. So this is my free, flowing thinking to get it to the next point. So thanks for joining me. Hope to see you again soon, and don't forget to subscribe.